It's wonderful to see everybody here. If I may have your attention, we are about to start the proceedings leading to the official unveiling of the lettering behind the black curtain. I know you all wonder what it's written there. In any case, you'll hear a few speeches and then you'll get to see the letters. So it's my great pleasure to yield the lectern to our Chancellor, Gene Block, somebody who in his 8 years, I think it's 8 years at UCLA, has done some amazing things. 9 years, wow.
9.5.
Wow, almost going on 10. Wow, has done some amazing things for this institution. And he is actually honoring us with his presence to say a few words about the new Manny Bhaumik Institute for Theoretical Physics.
Thank you. Thank you. Thank you, Joe. And was a great dean, is a great ex-dean right now. It's good afternoon, everyone, and I'm pleased that we're all here to celebrate the opening of the Manny Bhaumik Institute for Theoretical Physics. So, of course, we wouldn't be here today. We wouldn't be celebrating if it weren't for the generosity of Manny Bhaumik, who envisioned a place where the greatest talent in the country could come together to ask fundamental questions of physics that could be explored here. Manny's generous gift provides much-needed resources to further important research and discovery taking place here every day. Perhaps just as important, it represents how much our community around us supports UCLA. You know, I've said this many times, state support is critical for this institution, and it would take actually an extraordinary endowment to replace state support. But the truly special things, the dazzling things that go on at this institution, whether it be research or service, really depends on the generosity of people like Manny. And this is really an example where this has happened. So thanks to Manny, we now join a handful of elite research universities with an institute dedicated to theoretical physics. So this is really a singular achievement for our institution. The Department of Physics and Astronomy already has an incredibly diverse research portfolio from subatomic to supermassive. Our faculty work alongside really outstanding graduate and undergraduate students to unravel puzzles that have consumed our curiosity since the beginning of civilization. So, as we all know, extraordinary research. And the Bhaumik Institute will now extend our reach into the unknown. The remarkable gathering of scholars who've come here this afternoon is further proof that this gift casts a new and bright spotlight on the study of physics at UCLA. So it helps heighten the importance of this field and guarantees that we'll remain a leader. We're honored to welcome Nobel laureate and UC Santa Barbara faculty member David Gross, who's with us today. He's an extraordinary world-class physicist and mathematician and one of the really luminaries on Bhaumik's Institute's advisory board. So the Institute has put together, as it should, the best people in the world to advise them, and that guarantees that we'll make good decisions. So I'm confident that this will be the first of many occasions when the Institute brings together the best and brightest thinkers in the field. So in recognition of your generosity, we're proud to name this Institute in your name, Manny. So the Institute will be named after Manny. And we want to thank him for believing in UCLA, for investing in outstanding scholars who will push the boundaries of knowledge. So as again, I say, you know, it's not so often that you get individual philanthropists who believe in fundamental science and curiosity-driven science, and to support it at this level really is extraordinary. So we'd really like to thank him again for all that he has done. And I'm going to invite him to say a few words, but before, I'd like him to join me in a special unveiling of a new sign. So if Manny, if you can step forward, we will. And now a few words from Manny Bhaumik, and once again, let's thank him again for his generosity.
Thank you, everybody. especially Chancellor Block. Actually, I don't think you want to see a grown man cry, and I'll try not to, because this is a historic day in my life, just as it was when I first came and stepped foot on these hallowed grounds of UCLA, of venerated UCLA, way back in early May 1959, along with another gentleman from my native country, India, Professor Vishwanathan, who is here, who actually started the electrical engineering department and was the Senate chairman. And I'm glad to see him here. And even though it has been so long ago, I still have a very vivid memory of that day, because it's really hard how to really describe that. I felt like as if I am in a trance, going in a fantasy land. The best way I could probably describe that I've died and gone to heaven. But the most interesting part, of course, among other things, was the very stimulating, enthusiastic atmosphere that I found in the academia. Of course, I had some impression about campus life in US from watching Hollywood movies. But on that particular day in May, the reality actually surpassed my wildest imagination. I really was so impressed with that it is so vivid in my memory and it has really changed my life forever. And all this was possible because I was lucky enough to receive a Sloan Foundation fellowship, postdoctoral fellowship from UCLA. And later I learned that it had something to do with my mentor, the theorist, Professor S.N. Bose of Bose-Einstein fame. So today, I really feel exhilarated as I feel way back in 1959, because in my little way, I'm able to give something back to the effort that Chancellor Block has started to raise such a large amount, $4.2 billion for the centennial. And as he said, it's very hard to get money for theoretical physics, especially even for other physical sciences. And to my surprise, my little contribution was the largest ever in physical sciences. That surprised me. And because there are hundreds of millions of dollars in engineering, med schools, and so forth. But when it comes to fundamental science, especially theoretical physics, it's really, really hard to get money, not only from donors, but also from the government. And but anyway, it has all been possible for some very key people. Amongst them is, of course, the director, Zvi Warren. It was his dream, and it was his hard work and tenacious hard work that really made this possible, because this was the first time that an institute, endowed institute, has started in the physical sciences department. And people didn't know exactly how to go about and how to respond to it. So he had to soothe a lot of people that was not quite happy that it's not going their way. And but finally, yeah, it's really going very well. And so they had their first executive committee meeting. And like you said, I'm very happy that David Gross, who really transformed UCSB from a so-called party university to a very respectable physics university. And it was his foresight, wisdom. He never stops. It's amazing. And he's always traveling somewhere around the world in his age. And in fact, as you probably know, that having done his Nobel work on asymptotic freedom, which related to development of quantum chromodynamics, he was not satisfied. He went on to develop the heterotic string theory, and still, doing as much as he has been in his younger days. I don't know how he keeps up with it, and so I'm glad that we'll get the wisdom that he had gathered, not only at UCSB. He has been actually supporting, or rather advising, international institute in India called Indian Institute of Theoretical Sciences, and also he's going to China all the time, advising them. So David, we are really very blessed to have your involvement and advice. And in fact, he's a man who believes that there are three ingredients to make an institute great: excellence, excellence, and excellence. I'm repeating you, and that's what we're all looking for, an atmosphere that would be not only full of enthusiasm and excitement, but also bring excellence. And for me personally, I'm glad to see that I've been able to make a little contribution, take a little part, and it was really the help not only from the university, Chancellor. It is a joint effort that we had, and otherwise it would not have been possible. And that for generations to come, students like me that I came here would be able to come here and take part in the excellent, exciting, enthusiastic atmosphere that is going to be created in this institute. And so I want to thank also Professor Joe Rudnick, who, what is Joe? There he is here. Thank you, Joe. He and we are the two co-conspirators to get this thing going. And Brooke Sanders from the GIFT department, endowment department, has been made a really key part to make this possible, of course, without Chancellor Block. And with your vision, this would never been possible. Thank you. I'm taking too much time, but I just had to say that it is a historic day in my life. Thank you so much.
So early on in my term as Dean of Physical Sciences, I was called upon to give a report of my activities. And I'd only been on the job for about 3 months or so. And preparing for the talk, I reviewed my experiences and came to the conclusion that the principal occupations of someone in my position were twofold. First, you push paper, and second, you put out fires. And in fact, in terms of the time that filled my working days over the almost 10 years subsequently, that pretty much sums up the bulk of what I did from the time I walked in to my office in Mercy Hall to the time I turned in the keys and left. But there have been some genuine compensations, and they constitute the real reason in the end why I found my work as dean so rewarding. One of those compensations has been the opportunity to get to know some truly remarkable people. I clearly recall the breakfast meeting I had at the Bel Air Hotel restaurant, in which I made the acquaintance of an elegant, soft-spoken, and remarkably erudite man who actually remembered meeting me several decades previously at a party at my father's house. That was many years ago, and at that time I was at the age at which anybody over 25 was just part of an undifferentiated mass. So I actually had complete ignorance of that encounter. But what that also meant is that the time I spent with him at that breakfast and subsequently was for me a sequence of discoveries. I learned that Dr. Manny Bhaumik earned a doctorate in physics and theoretical physics, and that in his professional life, he led an important project at the Northrop Corporate Research Laboratory on the excimer laser that established its potential utility as a diagnostic and clinical tool. And in fact, you have been in proximity to one of those if you ever had LASIK surgery, because that's what it's used for, among many other things. I also learned that ever since childhood, Manny maintained a passion for science, and in particular for the foundations of modern physics, as well as a commitment to science education. But what I really learned was that he was and is an extraordinary individual. It has been a true joy to get to know Manny. And there's another compensation, and a particularly rewarding one of the job, and that's been the opportunity from time to time to participate in an initiative with the potential to change UCLA in profound ways. And the last and potentially most significant of those opportunities arose during a dinner conversation, again at the Bel Air Hotel, when Manny, Zvi, Byrne, and I began to talk about ways in which we could work together to foster excellence in the physical sciences. Well, that conversation escalated in a matter of days into a discussion of the possibility of establishing a privately funded Institute for Theoretical Physics at this institution. And this is something that would not exist if it were not for Manny's vision and his commitment to progress in fundamental research and education in the basic sciences. So once again, thank you, Manny. I believe that you will be remembered here as long as there is a UCLA. And I will certainly remember and deeply appreciate what you have done as long as I am around in this world. And now I turn to another significant figure who it is my distinct honor to introduce. David Gross is currently the Chancellor's Professor of Physics at the University of California, Santa Barbara. He was formerly director of the Kavli Institute for Theoretical Physics, a position that he held for 10 years, and he is now, to our profound gratitude, a member of the External Board of Advisors of the Manny Bhaumik Institute for Theoretical Physics. He's also one of the most important physicists of the last 40 years, whose work has shaped our understanding of fundamental process and indeed has formed the foundation for currently accepted models of the basic structure of matter and energy. Of course, somebody that important has received a number of honors, including a MacArthur Foundation Fellowship in 1987, the Dirac Medal in 1988, the Harvey Prize in 2000, and of course, the 2004 Nobel Prize in Physics for the work he performed with his graduate student at the time, Frank Wilczek, a highly distinguished physicist in his own right, a name that is as familiar to us as David's is, in which they established asymptotic freedom in the strong interactions. This work is one of the cornerstones of the theory of strong interactions, and as such will almost certainly endure as a fundamental physical truth, the kind of thing that will appear in textbooks as long as they are written. He has also contributed in essential ways to string theory, at this point the leading candidate for a theory of everything, and of particular note is the construction with 3 colleagues at Princeton. They're actually, 4 of them are now known as the Princeton String Quartet. of the heterotic string, one of the key contributions to what is now known as the first superstring revolution. More to the point, though, our new institute will benefit greatly from his passion for physics and his unwavering high standards. We are indeed fortunate that he's consented to serve on the Board of Advisors, and we are honored by his presence here. David.
Well, it really is a great pleasure to be here at this wonderful occasion, to see old friends, and to inaugurate this new Institute for Theoretical Physics. Now, I like institutes for theoretical physics. They serve a real, there can be institute as an overused, institute, center, whatever is an overused term. But there's a reason why there are an increasing number of institutes for theoretical physics. Physicists, theoretical physicists, unlike their public image, are actually an incredibly gregarious bunch. They don't sit alone in their laboratories working away or holed up in their offices calculating away. They, if they have the opportunity, spend a good part of their time interacting with their colleagues, exchanging ideas, competing, collaborating. That's how often the best physics, theoretical physics, is done. And institutes have flourished partly because they give theorists an opportunity to get together in workshops, conferences, programs, or just space in which they can exchange ideas and collaborate and learn about something in a totally different field. Theorists have the ability to span a subject because often their ideas developed in one area work in another, and much harder for experimentalists to do that. They have to work on their experiment. So institutes can bring together people, inform them of different ideas, in doing so stimulate what is called interdisciplinary research, which is an awful term, overused and rarely applied well, because the very notion of disciplines is sort of meaningless in science. There are no disciplines in science. There's just nature and the problems that nature poses. Institutes can break down these artificial departmental or subject areas. They can also enormously advance the careers and the prospects and the success of young scientists who are not yet formed, and in an atmosphere which is broad and exciting and interactive, young people can especially thrive. So I'm a great supporter and try to help institutes for theoretical physics around the world, and delighted that one is springing up here at UCLA. There are many people to congratulate, of course. I would start with Tzvi. I'll get to you. But, the real intellectual leader of this project, and who's poured a lot of his time and enormous energy and peace of mind into this project for years, but especially this last year, has been Tzvi. And I think he's done a great job so far, and he certainly seems to have the energy and the ambition to push it forward. But I'd also like to congratulate the department, which has been receptive to his ideas, to a dean of science who was quite remarkable in his support for this initiative and has helped it, through the university and the chancellor for supporting this effort and making it possible. But special thanks, of course, goes to Manny, who, as you've heard, I've gotten to know over the last few years and is indeed a remarkable human being, and one who grew up in physics with one of the physics greats as a mentor, and now and has never lost his love and passion for physics, but now has the opportunity to give back to the promotion of physics, especially in the field of which is so often hard to get support for, that is driven by curiosity and aims to understand the most fundamental problems, most fundamental structure of physical reality. There are not many people with the means and the passion to help in this endeavor, and Manny is one of them. So thank you very much, Manny, and thank you, UCLA. Thank you, Tzvi.
Thanks a lot, David. So when I started this quest of trying to build an institute here, I didn't realize how complicated it would be, and also how rewarding it would be. Well, first, I'd like to extend my deepest gratitude to Manny Bhaumik, not only for his generosity, but also his vision and understanding of the importance of fundamental theoretical physics, not only for UCLA, but also for all of humanity. So I'd like to thank Manny again. And then not only our donor, but of course, the administration and our colleagues and the development people, I'd really like to thank them as well. In particular, I would like to thank Joe Rudnick. There's our chair, Gene Turner, who unfortunately couldn't be here today, and then Brooke Sanders. So thank you again. Now, you might think in the modern era where we have the internet and we have Skype and we have email and we have blogs and tweets and all that other stuff, you might think that the gathering place for theoretical physicists is something obsolete, something so 20th century, we should forget about it. But I can assure you that it doesn't work that way, that a gathering place for theorists is just as relevant today as it was 50 years ago. The old-fashioned ways really do work. From my own personal experience, I can tell you that the only way to really do something of significance is to work with people and discuss, look at it from many different angles. It's also the way ideas spread, the cutting-edge ideas spread. And I can tell you that I can already see the benefits from our increased influx of visitors for our postdocs, for our students. It's already having an effect, and we're just getting started. So in today's environment with very tight funding, I think it's clear that only those universities that have endowed institutes will really be able to attract the best minds and the most exciting research. And I certainly expect that the Bhaumik Institute is going to help us take our rightful place among the very best universities. Because the institute is endowed, it really opens up possibilities far more than you could imagine if you're just relying on federal grants. Well, besides hosting postdocs and students, of course, we can bring visitors, we can run workshops, conferences, public lectures on cutting-edge topics. In fact, we've already started a very nice lecture series, which we're calling the Bhaumik series. And I can tell you that the people we've gotten to agree to come, they're really awesome. Now, this institute of ours, it of course starts from a very solid foundation, the Department of Physics and Astronomy. And of course, the primary goal of our institute is to maintain and expand that excellence. Now, because of our limitations, our plan is that we're going to initially focus on theoretical particle physics and issues related to questions of unification of forces and matter in nature. So there's a couple challenges I want to tell you about, the two primary challenges that we face. The first one is kind of an obvious one that every scientist faces, which how do we do work that captures the imagination not only of our colleagues but of the public in general. And then the other problem is, you may notice that the name of our institute is quite broad, Institute for Theoretical Physics. The question is, how do we help in all areas of theoretical physics without diluting the impact of our institute? Well, the first of these problems, that's completely usual. That's every scientist faces that, and we have had some success with that. But the second one, we do have a plan. And the plan is that we're going to have open membership in our institute, any theoretical physicist at UCLA broadly defined. And while our primary focus is going to be on particle physics, what we're going to do is support the junior faculty in all areas as best as we can. I think that's the best plan for having an impact with our limited resources. And of course, one of the important jobs of any director is fundraising so that we can do better in the future and really spread into all areas of theoretical physics. In any case, our institute will certainly be a very exciting place for our students, our faculty, and our postdocs. And for sure, our future has certainly never been brighter. It's really quite exciting. Well, thank you all for coming to celebrate this, and please enjoy the alcohol.